Good afternoon, everyone. I hope you guys have enjoyed previous lectures. In this lecture, we're going to be discussing about modularity and hierarchy in the context of object-oriented analysis and design. Previous lecture was focused on encapsulation, and continuing in the same line of discussion, we're going to be understanding what do we mean by modularity and hierarchy. Okay, so essentially modularity deals with about the partition the whole into pieces. So you have the whole system, full system, which you have at one abstract level. Now that system is encapsulating fine details within it. Okay, fine. So we abstracted the system, and then we learned the concept of encapsulation at a different abstraction level. Okay, now let's understand what do we mean by partition. So as we said that it is to partition the whole system. Now those partitions, whether those are manageable or not manageable. The essential idea here is that to partition uh, at one particular abstraction level into fine pieces which are loosely coupled together. Okay, those are coupled but loosely coupled. What do I mean? That, for example, let's say if you have this whole system, okay, now you decide I'm gonna partition it into two pieces. Okay, so let's say you wanna have one partition, you wanna have only two partition. Okay, now these partition, you can say one partition, two partition, S1, S2. And what is the relationship between S1 and S2? If you have, say, few connections, that means it's loosely coupled. Okay, and then loosely coupled means you not too much information is passing in between these two, S1 and S2, two partition. Okay, so it's a safe way to assume that this partition is fine. However, you may come up with situations where these S1 and S2 are tightly coupled, right? Then it becomes a bit complex problem if we do not have a better way to partition it. It's okay, but we have to manage the complexity of, say, passing too much information to and fro in these two entities. So if you have tightly coupled system, it is much better to put those tightly coupled modules in one big module. Okay, so here if you do that, that means that S1 and S2, when they are tightly coupled, are part of one system, one big block, you may say, which is communicating with another big block with a very minimal information transfer in between two blocks. Because remember, it's very similar to an analogy that you can easily exchange a bag, okay, with your friend, rather than it will be very quick and very easy, efficient, if you just put all your belongings, say 100 items in one bag, and give it to your friend and receive the same bag from your friend. But think about if you have to exchange 100 items individually with your friend, okay, it's gonna be tedious, difficult. In the same way, the idea of partitioning here is that we need to identify the portion of the system which are loosely coupled, and that we can make it a piece or a block, right? Let's talk about our favorite example of dog and fountain pen or ballpoint pen or digital pen. Okay, so just to make a more clear understanding, let's say you can, say, okay, it's a happy face, with a neck. I can, make it a block. Or you can also say like, leg, and then, this becomes one partition or one block. However, notice the difference here, that in this leg you have nails, and nails separately can become a one object or one block at a different level of abstraction. Okay, but one level of abstraction, we just say leg is one piece, and then rest of rest of the body and another leg. You can partition it that way. In the same way, you can partition the pen, say, front portion of the pen, back portion of the pen holder, okay, and the clip. Okay, you can do further partitions, but the idea here is the coupling. Okay, coupling between two partitions. So it is something to do the information exchange between two partitions. So remember, tightly coupled, you prefer it to put in one block and then create another boundary around that block, and then interface it with other modules in the system. If it is loosely coupled, we are good. So the idea is to identify the part of the system which can be encapsulated in one block, and those blocks are loosely coupled, so that we have minimal information exchange between those parts. And that gives another advantage as well, that the parts are working independently. Okay, that another concept comes concurrency, concurrent block. Let me write it down. Concurrency. Multiple parallel operations, for example. Okay, so say process P1, process P2 are working independently, or say this leg is working independently, this is working independently, and the whole system is working together. However, leg for this dog, it does its job, nail, it does its job, its tail, it does its job, but as a whole, system works. Concurrency, another concept. Okay, and later we come up with the concept of persistency. But those are the side concept. Persistent, okay, means the information storage or the object should be persistent. Or I mean, it's not that you have partitioned the system and you cannot store the information. So there got to be some way that for limited time, say for example, the image in the cache memory, or sometimes the object is present in the cache memory. Anyways, let's go back to the discussion of modularity. So as we said that, we can partition the digital pen or just a pen in 4 components, for example, and those are loosely coupled. Okay, but if you see the coupling between this little portion of the clip and the body of the clip, this is tightly coupled, it's same color or same thing. So the tightly coupled information, we put it in one block. Okay, it's like the body, like same color, and if we partition it same color, we have to we have to map individual pixel color so that the whole color of the body is same. So what we did, we partitioned it and put the rest of the body of same color in one big block. Okay, and these are four loosely coupled modules. So remember, tight coupling, loose coupling. Loose coupling make, individual blocks are working, and if it is, you identify that the certain portion is tightly coupled, you make a big block for all those components. Okay, and partition it that way. So remember, the modularity, it is the property of a system which allows to decompose the system into cohesive and loosely coupled modules. And then, your whole system is fine. Now let's talk about hierarchy. So in the coupling or in the modularity concept, we learned that we can partition the whole system into individual blocks. In hierarchy, it is simply the order in which order things are assembled. Okay? Or what sort of relationship is there between different parts of the system. For example, as we learned that we have four bigger modules of this digital pen. Now these are scrambled. These are not in order. So in hierarchy concept, that we need to have some sort of way of ordering these components so that when we put it together, we end up making the whole system, or the pen, for example. So you can say, okay, you rearrange these pieces together and it makes your pen. In the same way, when you're going to analyze this system, you need to think about the hierarchy at a different abstraction level. Okay. So for example, here, let's talk about just a clip. Just this clip. Okay. This clip object. Now this clip object, it has the property, or it is related with the pen top. Okay. It is sharing the property of the pen top. Okay. The clip will not go to the bottom. All right. Now clip will have a hook so that it can fit in your pocket. Okay. And clip also will have the property that it is made of gold. Okay, gold or silver, whatever metal is, but here I say it's made of gold. So see, the is a relationship. Now there is more to do with the relationship and with the hierarchy. The whole thing comes under the concept of inheritance. So you guys might have learned or might have heard about inheritance. Object-oriented programming languages offer capability of inheritance. So that's nothing but making facility for a hierarchical design. Let's take another example. Let's say we say an orange. Okay, so orange is related with the plant, orange tree, and also orange is related with the fruit. Okay, now so say in this way we have some sort of a hierarchy here, or we have some sort of a inheritance here for the orange object. Okay, so let's say parent. Okay, okay, so let's say parent is a class. You can say parent is a class, and so child will have its own attributes along with the shared attributes of parent. All right, so that sort of relationship. Okay, now if it is a boy, if it is a girl, then girl, both will have their own attributes along with the shared attributes of parent. That's a kind of example of inheritance. So this example may not be very perfect example, but this is just to give you an idea or overview of inheritance concept. We're gonna be learning about this when we're gonna talk about how to implement the inheritance. Okay, so this just gives an idea, right? So don't go by just by the words or it's not perfect or not. It's just to make you aware that how the hierarchical design or the what is the concept of hierarchy. It is just simply order. Make things in order. If there is no order, we would not be able to assemble the system back after we have partitioned it. All right. In other words, you can also think of it is ranking or ordering of abstractions. Hierarchy is nothing but the ranking or ordering of abstractions. How the different level of abstractions are interrelated, or what is the order in between them. For example, this orange is at one abstraction level, plant is at another abstraction level. Okay. So let's talk about what was our objective or what is the summary of our discussion. Object-oriented models help to harness the power of object-oriented programming languages. That's the major objective behind these concepts, okay, behind the object models. That object-oriented programming languages, we can make full use of the functionalities provided by these languages. Reusability. It simply says that write once and use multiple times, or in other words, you have written a code for a smaller block and you keep it in your library, okay, like you have used C libraries, C++ libraries. So write once and use it multiple times. Reusability. Okay. Stability. Once you have identified system, you have analyzed it at different abstraction levels, what is the relationship, what are different parts of the whole system, how they are working together, connected together, it improves the stability of your whole system, or in other words, software system. Okay. So now you are not concerned with the, let's say in traditional programming languages, you have data. Traditional programming languages, you have here data, and every subroutine is accessing, or subroutine or subprogram is accessing that data, right? Now here there is a danger that what if this subroutine modifies it? So you have to implement various kinds of locks and whatnot, okay, and bunch of other sort of problems. Now having the data along with its limited functions, okay, this whole object, right, this whole object is interacting with another objects, and it is working on its own private data, so it increases security that no other object is interfering or modifying its data, and of course inherent stability. So definitively the object-oriented theme or approach helps us here, and it reduces the risk for our software system for breaking down or unwanted attacks. Think about how many times your Windows machine get crashed. I mean, you work for a few hours and you see your Windows machine is getting crashed. Why? I mean, those are, it's a big company, employ many engineers. They might have used advanced concept, but inherently there is a problem. There might be that at the very core level, whoever has designed that in the very beginning might not be that perfect. Okay, and they are just creating a patching thing. Okay, we fix this patch, we fix that patch, and that patch, and that patch, but whole system is not stable. But let's say some other systems which are based on Unix are far more stable. Think about mainframes. Those computers are running on Linux, much more stable operating system. Okay. Anyways, so, and also, when we provided the stable software, it reduced the risk. Of course, our confidence in developing similar software, or it increases, it boosts up our confidence. Okay, yes, we can develop some smart systems, or some systems which are not crap, which are actually worth for the money and time spent. So thank you guys. I hope you have liked this lecture, and thank you for subscribing and your wonderful comments. Those who have not subscribed, please subscribe LeProfesseur channel on YouTube. We appreciate your feedback and your support. Have a wonderful day.